Hello, guys. Yeah, welcome back to our series. So the last time out, we stopped at flowcharts in our programming logics and techniques series. So, like I said, flowchart is the diagrammatic representation of our algorithm solution to a given problem. And we talked about the components of flowcharts. We said the oval indicates the starts and the stop of our algorithm. I would say the parallelogram is the inputs or is used to indicate an input into our algorithm, and we said the rectangle is the operations. The arrows is used to join the shapes, like you see here from the start to the read A, and the read A to read B, read B to the calculate sum, and then calculate sum to print sum, and then this is how our flowchart ends. And we mentioned also the algorithm is the expression or the layman way of representing the solution to our problem just before we code it. And we said there are some components that defines a perfect algorithm for us, and we said it should have an input, it should have an output, it must be definiteness, it must have definiteness, it must have finiteness, and also it must be accurate and precise. Yep, so these are like the components of algorithm, and we can see all these components right here within our flowcharts. The next thing we're going to look at is the pseudocode. Yeah, now we must have heard of the word pseudocode over and over again, right? Yeah, so here we're coming to understand the exact meaning of pseudocode and how to apply the word pseudocode. Well, pseudocode is nothing but what it is, a pseudocode, right? So it's a step-by-step description of our algorithm in code-like structure, only but it is in plain English. So pseudocode is also like your normal programming languages, like your programming code, only but you're just using English to express your programming code. Now, it is understood by programmers of all types. Now, you don't need to be a given kind of programmer, say C++, C Sharp, Java, PHP, to understand pseudocode. No matter what programming background you have, you can understand the pseudocode. Now, pseudocode can apply, is a given pseudocode can apply to every programming background and language. Now, it is understood by all programming background, and it cannot be compiled. So it is just English language, it is just written. So basically, it is handwritten or typed, it is not compilable. You can't compile and run a pseudocode. So that is the difference between pseudocode and your normal programming code. Pseudocode can be used in two programming paradigms, and it is basically used in the procedural programming paradigm or the OOP, which is the object oriented programming paradigm. Now, it means the pseudocode can apply to these different paradigms, whether you're using a procedural programming or an object oriented programming. So, when we say object oriented programming, we mean whether you're coding in classes and objects. Why procedural? You don't code in classes. Procedural is just from start, from top to bottom. That's procedural. All right. Now, understanding or looking at what pseudocode looks like, you're seeing what we have. The example one says, if a student's mark are greater than or equal to 40, print passed. Now, this is something like what you naturally type, what a developer would naturally type in his code. But this time around, you're not typing it, it is not a code, it is just plain English. Although you are using some keywords that a programmer will use in his code. For example, the if. the s, and the end if. These are all programming terms, right? Now pseudocode is similar to programming terms, but the slight difference is just it is English language and it can be compiled. See the example 2, you see enter a number, that's an input. If the DOM, okay, now enter a number and store it in num is a variable, we'll get to that very soon. If num modulus 2, now you're seeing the percentage sign here. I just mentioned something, modulus. Now modulus is an operator, don't forget, we'll get to that too. Modulus 2 equal 0, print the number is even. Now these are all programming structure basically, but it is not programming. This is no language, there is no language here, it is simply a pseudocode. So all of this you're seeing here, a layman can read it and understand what the program will likely do, only but he needs to understand at least one programming language to be able to convert this into that programming language and run it in that programming language. So this is what pseudocode does. If you can understand this, you can write it in Java, you can write it in C++, you can write it in C# or in JavaScript, whatever comes your way, whichever one you know best. You can write, you can convert your pseudocode into your program using the paradigms that you understand. All right. The next we're going to look at is decision making. Now, decision making is a process of making choices by identifying a decision, gathering information, and assessing alternative solutions. So, it is a simple vocabulary word or vocabulary definition of decision making. You're just trying to make a decision given the choices presented to you. Now, decision making statements in programming language decide the direction and the flow of a program. The same way you defined it in vocabulary term, now we're bringing it into the programming world. Now, we are to use certain statements or keywords when dealing with decision making in programming, and basically it is mostly if else, and so on and so forth. Now, if, of course, you're basically looking at something of this nature, if exactly, and then else also can be used in the same part, the same method as well, right? If else, so if a condition, else means the condition of the if is not met, right? Good. Now the nested if is such that has an if inside of another if, or an if inside of an else, is called a nested if. All right, an if inside of another if, or an if inside an else. So I'll use this as an example again. If a student's mark are greater than or equal to 40, you don't print. Now you come into this block and write another if the student is a male, print male has passed. Now you're using an if and another if inside this if. Is called a nested if. Now there's chained if. Chained if is the one you have if and else chained together. So it's mostly called else if in some languages like PHP, JavaScript. Yeah, so else if is a chained if that is used in some languages, right? Now you can use it here, but maybe I can't get a scenario right now, but definitely it can be used. All right, then the next if is the compound test if. The compound test if is you having just one if statement but multiple conditions within the if statement. It's called a compound test if. Yeah, so that is basically that about decision making. So very quickly before we end of this series, this episode, we're looking at variables. What are variables? Variables are used to store information. So people will say variables are placeholders for information that can be manipulated within the program. That is what variables are. It's a placeholder for information or data that can be manipulated in a computer program. Now, there are basically five types of variables that we can come across when programming. The first is a constant. Constants are, like the word implies, not changing. Constant. They are actually constant, right? They are static. So when you define a variable as a constant, you can't change that variable. You can't change the value of the variable, basically, right? So, and it is always written in capitals. All right. Now, global variables are variables that are defined within the top of the class and can be used by every method within that class. So right now I'm bringing in some terminologies that we've not even gotten into, but then yeah, you just understand this, right? So global variables are mostly used within a class and is used at the very top of the class. Now, if it's in a procedural paradigm, global variables are defined at the head of the particular page outside any function. So it is not defined within the function. Why the local variable is the opposite of the global variable. The local variables are defined within the functions in a procedural paradigm. Then in an OOP environment, the local variables are defined within the methods of a class. Within the methods of a class. So why the global variables are defined at the head without the method, at top of every method, the local variables are defined within a given method of a class. Then there are the class variables. The class variables are not so much used, right? Yeah, but they exist. You start writing them using a double at, and then the instances a single at, right? So most likely you'll be making use of the first three, and then the last two not commonly used. So yeah, that is that for this episode. Now next episode we'll continue from where we stopped, and we'll be looking at basic data types. For now, thank you, and make sure you subscribe and recommend this to your friends. Ciao.